Hello everyone, welcome to session 3 of module 1, 7 principles of testing. In this session, I'll explain you one by one the 7 principles of testing. So let's get started. So there are 7 testing principles which offer general guidelines for common for all testing. So 7 testing principles are: testing shows the presence of defect. Exhaustive testing is impossible. Then third principle is early testing. Fourth principle says defect clustering. Fifth principle says pesticide paradox. Sixth principle is testing is context dependent. And seventh and last principle is absence of error fallacy. So we'll understand these principles one by one. So principle 1, testing shows the presence of defects. What does it mean? So testing can show that defects are present, but testing cannot prove that there are no defects in the software. So this principle means that when you are testing something, when you are testing a software, you find defects. And that way you can say that there are defects in the software, but you can never claim, you can never say, you cannot prove that there are no defects in the software. Even if in the later cycles when you stop finding critical defects, but still when the software goes into production, there might be some environmental changes or environmental configuration or hardware configuration in the production environment that might cause the software to fail. So you can never prove that there are no defects in the software. A software can fail anytime. So testing reduces the risk of failure, but it can never prove that your software that you have tested is 100% defect free. Testing reduces the probability of undiscovered defects remaining in the software, but even if no defects are found, it does not prove, it is not a proof of correctness. Okay, so testing reduces the probability of undiscovered defects. So once you start testing, you find more and more defects, and in the later phases of the software development, in the testing cycle, you start finding very less defects because you have almost discovered most of the obvious defects. But still, it is not proof of the correctness that your software is completely correct and defect free. So for example, let's take an example to understand this. And in ISTQB book, there is a very good example about explaining this principle. So if you only see white swans, you can say that all swans are white. But as soon as you see one black swan, so you cannot say all swans are white. So similarly, in software context, if you are executing test cases and you have executed hundreds of test cases and you did not find any defects in those test cases till now that you have executed, you still cannot say that there are no defects in the software, because there might be defects in other areas of the software, in other execution or in other scenario that you would be testing in future. So it doesn't depend. I mean, as soon as you find one bug, you can say that software is not defect free. All right. So just understand the context of the swans, that as soon as you see the black swan, you cannot say that all swans are white. So similarly, as soon as you find one defect in a software, you cannot say that software is defect free. So that's principle number one, that testing shows the presence of defects, but it doesn't prove that there are no defects in the software. Principle 2 says exhaustive testing is impossible. Why is exhaustive testing impossible? We will understand by taking certain examples and see why you cannot test a software exhaustively. Testing everything, all combinations of inputs and preconditions, is not feasible except for trivial cases or very small cases. So if you have very small scenarios wherein you just want to cover all the combinations or input, you can do that, but for complex combinations it's not possible to cover all the preconditions or all the input conditions for testing. Instead of exhaustive testing, we use risks and priorities to focus testing efforts. So we do not do exhaustive testing. We prioritize our test cases, our test efforts based on the risks. So if a module has high risk, so we prioritize our testing based on that, and instead of testing everything, we used proper test design techniques to test the boundary conditions like boundary value analysis, equivalence partitioning. Rather than testing everything, you just find the valid partition and invalid partition, apply boundary value analysis, test conditions there and test it, rather than testing all the input combinations and preconditions. So based on the risk and priorities, you need to focus the testing efforts. So why exhaustive testing is impossible? Let's take an example for this. So can you imagine how many tests would you need to do complete test for a one-digit numeric field? So suppose on a web page you just have a text field which just accepts one-digit numeric field. How many test cases can you think of for that single scenario if you are doing an exhaustive testing? So one-digit numeric field will be having 10 inputs of the valid numbers, that is 0 to 9. So valid values 10 numbers. Then invalid scenarios could be 26 lowercase characters, 26 uppercase characters, and then some of the special characters and punctuation and blank value. So if you sum up these, it comes to somewhere around 68 to 70 tests for this example, just one digit on a text on a web page, where you need to, if you are going for exhaustive testing, you'll be having 68 to 70 tests to do. That is still, you can do that if you want, but it is still 70 test cases and not advisable to do those test cases at all. There are better techniques to design your test cases and achieve the coverage that you want with those test cases if you do better test design for these scenarios. Then example 2. So if we take an example where one screen has 15 input field and each having 5 possible values, then to test all of the valid input combinations you would need 5 to the power 15 tests, which comes to the huge number you can see on the screen. So each input, there are 15 input field, each input field accepts 5 possible values. So you can see the number of combinations that you need to execute to test, to do exhaustive testing of that one web page. And you can imagine in banking and e-commerce websites, there are, in every page there are 10 to 15 input fields which accept more than 5 values. So it is very unlikely that the project timescales would allow for this number of tests to execute. Okay, so that is why principle 2 says exhaustive testing is impossible. You cannot test all the input conditions, input combinations, and preconditions for the software. In order to get similar kind of coverage, you need to adopt better test design techniques like equivalence partitioning, boundary value analysis to design your test cases so that you get best coverage for the software. Principle 3 says early testing. Testing activities should start as early as possible in the software development lifecycle and should be focused on defined objectives. So early testing is the key for better quality software. If you do not start testing early, the quality of software is definitely going to be affected. You cannot expect a better quality software if you do not start testing early. Okay, so this is pretty self-explanatory. That testing activities should start as early as possible in SDLC. So early testing, like early test design and review activities, should start because it's cheap to find and fix defects in initial phases of SDLC. So once SDLC starts, once the requirements gathering starts, once the design phase starts, once the coding starts, so testing should be involved from those initial phases of SDLC, from the requirements itself, so that if there is any gap in the requirements are not clear, the requirements are not testable, testers can provide their inputs into the requirement or into the design, and that can be rectified in the initial phases itself, rather than finding defects in the testing phase and then again going back and changing requirement, changing design, which costs you a lot of money and a lot of time already wasted. So early testing is the third principle. So your testing should start as early as possible in SDLC. After development, objective should be to find as many integration system defects as you can. So since the testing should start as early as possible, so most of the requirements should be requirement defect or design defect should be able to, testers should be able to find in the early phases itself. And the objective of each phase after development is done should be to find as many integration or system defects as the testers can. The user acceptance testing or UAT testing UAT objective should be to find out if the software meets end user requirements. So these are the defined objectives of different phases, different testing phases. So in the early testing, in the early phases of SDLC, testing should focus on finding any design or requirement issues. In the functional testing and system testing phases, testing should focus on finding as many integration or system defects as test team can. In user acceptance testing phase, the focus should be to find out if the software meets end user requirements or not. Then in maintenance testing, objective should be to ensure that there are no new defects introduced in the system by changing the software or fixing the defects. So that is known as regression testing. So in maintenance testing, if there is any change done in the software or fixes done in the software, so the focus should be to ensure that there are no new defects introduced into the software. And if we continue testing production use, main objective should be to assess system availability and reliability. So the main objective of testing a production environment is to ensure that the system is always available and reliable for the end user. So principle 3 says start testing as early as possible. Do not delay the testing process to later phases. Otherwise, it will be again huge amount of effort in rectifying those design or requirement issues and then again testing it. Principle 4 says defect clustering. So what does defect clustering means? It means that a small number of modules contain most of the defects discovered during pre-release testing or show most operational failures. So defect clustering means that there is in any software there are a small chunks or small modules in that software which have most number of defects are in those modules. So most of the testers have noticed that defects tend to cluster. Why it happens is because defect clustering happens because an area of code is complex and tricky. So if an area of code is complex or tricky, it will be implemented, there will be complexity involved in implementing that area or code, and because of that complexity involved, there will be more number of defects around that complex area. Then changing software and other products tend to cause knock-on defects. So this is also seen in the software, that whenever you change software or whenever you fix some defects in the software, it causes knock-on defects, causes more defects around the area. So that's the another cause of defect clustering. Then testers should use this information when making their risk assessment for planning the test and focus on known hotspots. So defect clustering information, like if you most of the testers would know about the complex areas, complex modules of the software, and they should take this information and they should use this information in doing risk assessment for planning their future test cases, because they know the hotspots, that these are the main areas, these are the main modules where most of the defects were in previous release, and there are changes coming around in these modules, and so there is high risk around these modules, and so the tester should focus proper test cases around those hotspots or those modules to test that thoroughly. Then the principle 5 says pesticide paradox. What does this mean? If the same tests are repeated over and over again, eventually the same set of test cases will no longer find any new bugs. So suppose you have a test suite which has 100 test cases, and in every build cycle, every build that you get from the developers, you execute same set of test cases without any modification for another, say, 5 to 6 cycles, you are not going to find any new defects in those test cases, because whatever defects were associated with those test cases have already been found, fixed and rectified. So same set of test cases will no longer find any new bugs for you. So that is what pesticide paradox means. So it's taken from the actual. So suppose you are using same sort of pesticide for agriculture to kill the insects of the crops. So eventually, after like 2-3 years, those insects are no longer being affected with the same kind of pesticide. So you need to change that. You need to change the pesticide to be it more effective on those kind of insects for the crop. So similarly, for the test cases, you need to modify the test cases again and again in order to find new bugs in the software. So if same set of test cases is repeated over and over again, you won't be able to find any new bugs in later cycles. So to overcome this pesticide paradox, the test cases need to be regularly reviewed and revised, and new and different tests need to be written to exercise different parts of the software or system to potentially find more defects. So in order to overcome this pesticide paradox, you need to update your test cases, you revise your test cases, and new test cases need to be added in that test suite so that you should be able to like find new defects around the software. So as the hotspots for bugs get cleaned up, we need to move our focus elsewhere, because some same set of tests would not find any more defects. So if there are hotspots like the modules which are complex and which have most number of failures, once those hotspots are being cleaned up and the test cases that you have are all passed around those hotspots, then those same test cases, if you execute again in the next cycle, it's very difficult to find any new defects around those hotspots, because those defects have already been fixed and passed the test cases. So same set of test cases will not find any more defects for those hotspots. So over time, focus should be changed from finding coding bugs to looking at like requirement bugs or design issues of the software. Then principle 6 says testing is context dependent. Testing is done differently in different contexts. For example, safety critical software is tested differently from an e-commerce site. So testing is context dependent means that testing is done differently in different contexts. Safety critical software will be tested differently from an e-commerce website. So not all software systems carry the same level of risk, so different approach is taken to test softwares in different contexts. So because safety critical applications have more risk associated with them, e-commerce site has lesser risk because it doesn't harm, it doesn't risk any human life so because of that, safety critical software is tested. The context or the way the safety critical software will be tested is different from the e-commerce site. So for example, if you have a family website where you just keep the information of your family members and details of your family members, ad hoc testing is enough. No tool is used, just manual testing is enough for that. But if you're testing an e-commerce application, so see how context changes. So family website is also a website, e-commerce applications is also a website, your shopping website. So more testing needs to be done for this website's functional, non-functional attributes, and different tools are also used, and general company procedures and guidelines are followed. So since the context of family website and e-commerce application are different, that's why the testing done for e-commerce application is different from the family website. So similarly, if you take traffic control system, testing is done completely in different way, and different set of tools and technologies are used to test traffic control system, and much more strict testing guidelines need to be followed. strict entry and exit criteria needs to be followed for traffic control system, because it's very critical system and human lives are dependent on this traffic control system. It can cause severe, if there are failures in the traffic control system, it can cause severe damage to property and life of the people. So principle 6 says testing is context dependent, because software are different. So based on the context for which you are developing the software or testing the software, the way of testing that software, the tools that you use to test that software will be different. Now, seventh and last principle, absence of error fallacy. What does this mean is fixing and finding defects does not help if the system built is unusable and does not fulfill the user needs and expectations. So if you're testing a software, you are finding defects, all the defects are fixed, and your software is working perfectly fine, all the performance is good, you're getting good response from the software that you are testing, and it doesn't fail at all, it's very good quality, but it's not usable for the end user. It's not what an end user wanted, then it's of no use for the end user. So even if there are no errors in the software, it does not fulfill the user needs and it's unusable. So the customer who buys the software does not bother about number of defects until software directly affects them and is unstable to use. So they are more interested in software fulfilling their requirements and does what they want it to do. Okay. So absence of error fallacy means that you can feel that software doesn't fail, it doesn't have any major issues, major defects, it has good response time, but if it is not usable, it is of no use for the end user. Okay. So that's what principle 7 says. So the software that you're delivering should meet end user needs and expectations. It should be defect free, it should have good performance, and it should fulfill the end user needs and expectations. So to conclude, in this session we learned 7 principles of testing and understood in detail what all these seven principles of testing means. So testing shows the presence of defects. It does not show that there are no defects in the software. Exhaustive testing is impossible. You cannot test all the input combinations of the software. Early testing means you start your software testing activities as early as possible in software development lifecycle. Defect clustering means there are some modules in the software which are complex or not implemented in a right way, which contain the maximum number of defects in the software. And pesticide paradox, if you are using same number of test cases again and again in your future test cycles, you are not going to find any new defects in future unless until you modify and update your test cases with new test cases and new input data. Then testing is context dependent. So testing is done differently in different contexts. An e-commerce website will be tested differently from a safety critical or air traffic control system. Then absence of error fallacy is the last principle, which says that the software that you're delivering should be usable, even if it has no defects and it does not fail, if it is not user friendly and if it is not what an end user wants, then it makes no sense to deliver that software. So the software should be easy to use, defect free, and should do what an end user wants to do. So these are all 7 principles of testing. Thank you.